Okay. Welcome, ladies and gentlemen. We are looking at expanding vertex form into standard form. Now, the first thing we need to know is what is vertex form and what is standard form. Vertex form is what we've been dealing with. A, H's, and K. And it's called vertex form because you can see the vertex easily from here. The vertex is given by H comma K. We're going to be converting into standard form. Now, you've all been taught standard form in grade 10, and we're going to be going from this form into this form today, and after today, we're going to be going from this form back into this form. And the reason for that is that there's some good stuff being shown here, and there's good stuff being shown here. And being able to go back and forth gives us a lot of information. So, here I have a quadratic, y equals x minus 7 squared minus 8. I would like to first graph that quadratic using transformations. The first thing you should know is that this has a vertex of 7 comma negative 8. There should be no questions about that at this point. So 5, 6, 7, negative 8, that's negative 5, negative 6, negative 7, negative 8, making sure I line it up properly. And I think this is where it is. My live studio audience will let me know if I'm making a mistake. So there's my vertex. You should also know something else from this. You should know that it opens up. How do you know it opens up? Because the a value is positive. But sir, there's no a value there. Well, yeah, there is. There's an invisible 1. And that means it's going to be congruent to y equals x squared, which means it's going to have the same step pattern. Over 1, up 1 squared. Over 2, up 2 squared. So it's going to look like this.
So you're on the wrong dot.
I'm on the wrong dot? So 6, 7, so that's right. And I'm at, oh, I'm on the right dot. Yay! Okay, so where were we? We're doing the step pattern. Over 1, up 1. Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 2, up 4 from the vertex. 1, 2, 1, 2, 3, 4. Over 3, up 9. Now I'm at negative 8. So if I go up 9, I'm going to go up to 1. Does that make sense to everyone? Okay, so we're coming up like this. Now if I go over, that was 3. If I go over 4, I should go up 16. So negative 9, no, what is this, negative 8? So I should go up to positive 8. So 5, 6, 7, 8. And this is to come off the screen now. And it's obvious that I'm not going to be able to get this value over here either. Let's see if I can figure out what the y-intercept would be. If I let x equal 0, it would be negative 7 squared, which is 49. 49 minus 8 would be 41. So this y-intercept way up here somewhere would be 0 comma 41. Way up here somewhere, it's going to cross the y-axis. But this is what we know so far. It's going to look something like this. Okay? So that's kind of cool. That's what we know. And again, this is going to be 0 comma, I think we said 41. 7 squared is 49, take away 8, 41. Yep, and it's going to go way up to that point. Okay, so let's expand this quadratic to put it into standard form. So this is what it looked like. We want to expand it. So using our algebra skills, what this really means is so now I have two binomials that need to be multiplied together first, according to BEDMAS, and then subtract 8. So x times x is x squared, negative 7x, negative 7x, negative 7 times negative 7 is positive 49, minus 8. And I'm going to get x squared, negative 7x, and another negative 7x is negative 14x's, plus 41. So my standard form is y equals x squared minus 14x plus 41. And you'll notice that when I take it apart and determine what A is 1, B is negative 14, and C is 41 in this case. That's it. Nothing really spectacular here, just taking a look at it. Although, maybe we could notice something. Do you see something about this 41? See it way up there? That 41 actually is way up there. And we're going to keep our eyes on that. We're going to notice that that's going to happen over and over again. So let's look at the next one, if we're all set. Oh, wait a moment. Okay. So we'll take a look at this one. So the vertex. We should know that the vertex is going to be at negative 3, 5. So negative 3, 1, 2, 3, up to 5. My studio audience will let me know if I've made a mistake. We should notice that the A is negative 2. So it's going to open down. And you should also know that it's got a vertical stretch to it, doesn't it? And so it's going to open down in a stretched format. So it's going to be over 1 down 2, because it's 2 times 1 squared. And then it's going to be over 2 down 8, because again, that step pattern has changed. So this is over x down 2x squared. So over 1 down 2. Over 1 down 2. Over 2 down 8. So that's 5, 6, 7, 8. Over 3 would be down 18. Not sure if I've got enough to do that. I don't. So it would be down here somewhere. So this is 5. So that's going down 15, 16, 17, 18. So that'll be negative 11, negative 12, negative 13. So 0, negative 13. Well, you can't see. I'm sorry. So I'm down here. So the question now is, can we check that? What if x is 0? Let's put it in here. So if x is 0, it's 3 squared, which is 9, times 2, negative 2, which is negative 18. Negative 18 plus 5 is negative 13. So it's right. I got it right. That's going to be where it's crossing the y-axis. So it's going to look something like this. And again, I've drawn it lopsided, but you know what I'm talking about, right? Nothing wrong with doing that. Just looks weird. Yeah?
Do we do it like that on a test, or do we have to extend the other side of it too?
I'm okay if you do that on a test. You're giving me what's important. Really, what's happening over here is not that important, really. So I'm actually okay with that. Okay, let's expand this to put it in standard form. So what it was y equals negative 2 x plus 3 squared plus 5. Order of operations is kicking in here. So this is going to be y equals negative 2 x plus 3 plus 5. Now we have an option. We can take that negative 2 and put it into this bracket, or we can take that negative 2 and put it into this bracket. You can't put it into both. And your third option is to expand out your two binomials first and then put the negative 2 in. That's probably what I'm going to suggest that you do most times. If you wish to take the negative 2 and make it negative 2x, negative 6 first, it would look like this. Negative 2x minus 6. And you know what? There's nothing wrong with doing it this way either. That's perfectly acceptable. And then we're going to expand these binomials. So 2x times x is negative 2x squared. Negative 2x times 3 is negative 6x. Negative 6x again. Negative 18. And don't forget about your plus 5. So this is going to be y equals negative 2x squared, negative 12x, negative 18 plus 5 is negative 13. And that's in standard form. Do you see something interesting? That 13 is shown up again, that negative 13. They share the same a value, don't they? So there's some things that are similar here. The a value stays the same for both of them. The b, not really sure what that negative 12 is. But that c, that seems to be your y-intercept, doesn't it? That's kind of cool. So vertex form shows you the vertex, and standard form seems to be showing me the y-intercept, and they both show me the step pattern and the direction of opening. Now, the other way to expand this, just so that I'm sure that I've taught you everything that you need to know, is to do the following. Y equals negative 2, x plus 3 squared plus 5. So you would do negative 2, x plus 3, x plus 3, negative 5. And if you chose to, put these two together first and leave the negative 2 on the outside. X squared plus 3x plus 3x plus 9 minus 5. Put these two together.
Yeah, is it plus 5 or minus?
Plus 5, thank you.
Oh.
I'm glad I have a studio audience. Negative 2, x squared plus 6x plus 9 plus 5. The negative 2 goes in to the brackets, not to the 5. It's not inside the brackets. So it's going to be negative 2x squared minus 12x minus 18 plus 5. Negative 2x squared minus 12x minus 13, which, lo and behold, is the same answer we got here. Doesn't matter which way you do it, both are grand. Do one way, do the other way, get it right. Okay, so we're going to flip this page over. Number 3. A student expanded the following equation from vertex form into standard form. Explain in words what they did in each line of their solution. Fill in the missing steps. So, that's the original equation. What did he do here? Well, he wrote the x squared. It says in words, but I have a hard time putting this in words. He wrote the exponent out, so the base was twice. And if I say in words, and if you draw me a picture like that, that's good enough, okay? That's mathematical words to me. What's he doing next? Well, this one really should do words. He took the 5 inside, didn't he? So he expanded the 5 into one of the binomials. What's another word for expanded? You could have said distributed. Either one of those words work for me really well. And that's what's happening here. So we took that 5 and it went in to give me this. So I multiply the second bracket by each term in the first bracket. So that should look like this. So what I basically did was I took every term here and we expanded it out. What did we do next? Well, what they're trying to show you is they get rid of the brackets. They dropped the brackets. There's only a 1 out here, so we get rid of the brackets. If there was a number on the outside here, we'd have to deal with it, but we took care of that already. And finally, we collected like terms. The official word for that is simplified. Ladies and gentlemen, what I'd like you to do now is the practice below. There's 4 questions. There are answers at the bottom. And if you make a mistake and you don't get the answer, please try photo math, see if that'll work. You got to tell it to expand. And if that doesn't work, go back over the video, see what I did, and find your mistake.